वाले क्षणों का साक्षी बनने हेतु हम अपने को कृतज्ञ महसूस करते हैं। इस समय आप केंद्र में उपस्थित इस सभागार में बाकायदा 1 मिनट 7 सेकंड की दूरी पर हमारी धड़कनें इस समय गिनी जा सकती हैं। इस हॉल में उपस्थित जितने भी वैज्ञानिक हैं, जितने भी वरिष्ठ वैज्ञानिक हैं, जितने भी विशेषज्ञ हैं, सारी निगाहें केवल आंकड़ों पर, क्योंकि सारे आंकड़े उपग्रह अपने आप स्वायत्तता के हिसाब से लेता जा रहा है और गतिविधियों को अंजाम देता जा रहा है। आपको शायद वो घड़ी याद हो जब पिछली बार उपग्रह में लगे 440 न्यूटन वाले तरल इंजन का प्रयोग किया गया था। जी हाँ, लगभग 300 दिन पहले, और उसके बाद उसके सभी वाल्वों को क्या किया गया था। दरअसल इसका
काम हो गया तो ठीक है, देख लिया
क्योंकि तरल इंजन में केवल सोलेनॉइड वाल्व होता है, जबकि एओसीएस में इस वाल्व के साथ साथ आइसोलेशन वाल्व का भी प्रयोग होता है। इसीलिए दूसरा कारण सोलेनॉइड वाल्व में प्रयुक्त पदार्थ लंबी अवधि तक मोनोमिथाइल हाइड्रोजन और नाइट्रोजन टेट्राऑक्साइड के संपर्क में आने से कुछ हो जाता है, जिससे द्रव प्रवाह में उत्पन्न बाधा से ज्वलन प्रभावित।
थोड़ी देर ना डिस्टर्ब मत करो, मुझे काम कर रहा हूँ यहाँ पे।
कंप्यूटर में हो रहा है।
Including orbit and attitude maintenance in Mars orbit. The propulsion system carries the required propellant from the designed mission by with adequate margin. The spacecraft propulsion subsystem is designed for attitude and orbit control during the different phases of the mission.
Yes, there is a confirmation of the burn start and the entire frequency gathered has erupted. The accelerometer has now shown a delta V of 23.4 meters per second, and the burn has started as per the exact timeline, and it is slowly inching 98.7 meters per second.
इस समय हम लगभग 1 मिनट 22 सेकंड व्यतीत कर चुके हैं जब हमारा प्रज्वलन तरल इंजन का आगे बढ़ चुका है। इसरो के चेयरमैन और स्पेस एप्लीकेशन सेंटर अहमदाबाद के निदेशक महोदय, ये आप चित्रांकन देख पा रहे हैं जब लैंप 440 मीटर का उसके साथ जो प्रमोद है वो भी फायर करता है। इस समय बहुत महत्वपूर्ण होता है इन सभी का निष्पादन।
Now there is another important event going to happen during this burn. This is due to the geometry of Earth, Mars and MOM. Earlier, there was an eclipse event when Mars came in between MOM and the sun rays couldn't reach the spacecraft and it was in eclipse. Now consider the Earth to MOM link, which makes communication between the two possible. During and right, the Earth and MOM are near or the hidden by Mars from ground station or the station of MOM by Mars will start around 4.5 after around 7:34 a.m. on the ground. The ground mission will not be able to receive any spacecraft telemetry which the MOM sends during this occult period. In terms of the delayed reception on the ground, we will be getting spacecraft telemetry till about 7:34 a.m. The occultation extends for about 24 minutes, that is 3.5 minutes beyond the expected end of burn. However, we would have to wait for another 2.5 minutes to get spacecraft telemetry till the MGA communication antenna establishes a link with the Earth ground station. So the expected telemetry break is for about 26 minutes, that's 30 a.m. to 8 a.m.
जी हाँ नागदा जी, स्थित भूकेंद्र और उपग्रह के बीच संकेतों के आदान प्रदान में रुकावट आ जाती है, किंतु उपग्रह के परावलय पथ का ये वो हिस्सा है जहां तरल इंजन के प्रज्वलन को हर हाल में प्रज्वलन पड़ता है। सवाल उठता है कि कैसे? इस तरह से आप देख पा रहे हैं अपने स्क्रीन पे, प्रज्वलन लगातार जारी है। इसरो के वैज्ञानिकों ने इसका भी तोड़ निकाल ही लिया। एलपीएससी के वैज्ञानिकों के अथक परिश्रम के बाद वो किसी स्थितियों का अनुकरण करते हुए हाई एल्टीट्यूड टेस्ट हैट में 2 तरल इंजनों का में 4 दिन की परिस्थितियों को अनुकरित कर परीक्षण किया तो वो बेहद उत्साहवर्धक था। अब दिसंबर की जब उपग्रह को ऐसे ही परीक्षण के लिए लगभग 4 सेकंड के परीक्षण से गुजारा गया और ये सुनिश्चित कि हाँ हम आकल की स्थिति में स्वायत्तता के साथ प्रज्वलन प्रक्रिया को सुचारू रूप से पूरा कर सकते हैं। इस समय हम करीब 4 मिनट 50 सेकंड प्रज्वलन का व्यतीत करते हैं और करीब 14 मिनट 30 सेकंड बचे हैं। मंगल में प्रवेश कराना था तो ग्रहण की उपस्थिति में इसे और भी संकटपूर्ण बना दिया, पर इस समस्या से जूझने के लिए भी वैज्ञानिक ने पावर को कम किया और औसतन 850 वाट से घटाकर मात्र 320 आवश्यक था। करीब 100 वाट और एक ट्रांसमीटर करीब 30 वाट और करीब 60 वाट के तापक या हीटर को भी स्विच ऑफ कर दिया गया और इस तरह से इतनी कठिन घड़ी के इन सरसंघों की सोच, परिश्रम और लगन ने आसानी से हल कर दिया। आप प्रोफेसर यशपाल को अपने स्क्रीन पर देख पा रहे होंगे। हम लोग प्रज्वलन को बाकायदा देख पा रहे हैं। 5 मिनट 57 सेकंड व्यतीत हो चुके हैं और हम लोग 13 मिनट 27 सेकंड दूर हैं।
Orbit can be seen as the path for the satellite, and it has some complexities. There certainly is a matter of concern for the scientists. To be able to meet these challenges, certain innovative solutions have been devised. It all starts with the launch itself. The launch vehicle needs continuous tracking. The major landmarks of this orbital can be phases, namely the Earth-bound or geocentric phase, heliocentric or cruise phase, and the Mars orbit phase. The prime responsibility to monitor and ensure the performance of the satellite in all the phases of the mission lies with the ISRO Satellite Telemetry, Tracking and Command Center, that is, ISTRAC, situated at Bangalore. As the vehicle traveled through the atmosphere, its first stage and the strap-ons burned and separated from the vehicle, and subsequently the second stage liquid engine took over. When the vehicle moved away from the atmosphere, the heat shields separated and the second stage handed over the flight to the third stage. All these operations were technically complex and their successful completion underlines the reliability of the system. During the first 3 stages of the flight, ISTRAC downlink stations located at Bangalore, Srihari, Port Blair, Brunei and Bihar tracked the vehicle and continuously delivered the vehicle telemetry to the control center. Here again, the information on the path of the launch vehicle was crucial. The rocket then entered a long course phase of unpowered hyperbolic trajectory for a duration of about 26 minutes. When the vehicle was out of sight from the Bihar ground station, there was a gap of 10 minutes where it was not visible on the monitors of any of the ground stations. To manage and handle this very challenging flying period, elaborate planning was done. When ground stations were positioned to track the vehicle, 2 ships, Nalanda and yet on tracking antenna for the Western Pacific Ocean. To have these two ships for tracking was so crucial and important for the mission that the date of the launch of the mission had to be rescheduled, as initially these ships would not reach the pre-identified location due to bad weather. The ships were equipped with state-of-the-art indigenous transportable terminals, a technological marvel developed in our country. These are only two of its kind and were engaged exclusively for the mission. Subsequently, all went as planned. The antennas provided necessary telemetry and tracking data to monitor the critical events of the vehicle. The first ship was located at such a position where it could monitor the ignition of the fourth stage liquid rocket engine. The location of the second ship was carefully chosen to monitor the burnout of the fourth stage and satellite separation. At the end of the flight, the spacecraft was injected successfully in the designated orbit around the Earth. Then started the Earthbound phase to achieve the Trans-Mars insertion operation. Here it was required to raise the apogee altitudes in every successive orbit with proper velocity and thrust. It was challenging, critical, to bring code liquid apogee motor, that is, LAP. At the end of the maneuver, the apogee of the orbit was raised to a higher altitude. Following this, the spacecraft reoriented itself to its normal orientation. This is known as reverse rotation. It would be interesting to note at this juncture that the autonomous fault detection and recovery programs loaded in the onboard flight computer, which are crucial for successful operation of the Mars orbit insertion, that is MOI maneuver, were enabled and tested in the Earth-burn 4 maneuver, that is EBN 4 maneuver. One of the features was tested for the first time, which resulted only into partial burn. It was correct with subsequent for their operation were given from the ISRO Mission Operations Conference. At the end of EBN 5, the apogee altitude was at 1,92,000 kilometers, or around 2 lakh kilometers. The sixth and final Trans-Mars injection conducted on 1st December 2014 injected the spacecraft into a hyperbolic departure trajectory. After the sixth maneuver, spacecraft gradually moved away from Earth on 3rd December 2013. It escaped from the Earth's sphere of influence. From there on, the spacecraft went on an image-centric track. The spacecraft was initially traveling ahead of Earth in